That's good. All right, guys, let's go. Science standards.
What's up, Mom?
How's your science? Get project done. Let's go.
Huh?
She got a dude.
I just said what's up to her. I know, don't you go with my home?
Good. I know for sure. Not Jessica.
Jeremiah.
Yeah. So, what we're going to do, guys, is talk about the science standards. For basically, I'll do a little bit of overview of all the classes, how to find them, how to look at them, what you can do to make a project out of them, right? And whether it could be a project where you write a story, you create a model, you do an experiment. It's up to you. Right? We'll do the basics on that. Now, somewhere along the way, you should have had the student standards folder shared with you. If you haven't, at the end here, let me know, and I will do that. If you came to listen to your music, just go away.
Huh?
Just go away.
What you mean? No, I will tell you something. My mom will take you.
Okay. Alright. So turn the music off. Whoever's got it. No point in being here if you're not going to pay attention. You're just distracting others. So in there, you see there's the business standards, there's engineering stuff. Actually, one of these needs to go away. There's probably two of them. Math, science. We're adding English and social studies. There's a bunch of other standards here. So we're looking at science right now. So in the science, here are all the different sciences that are happening down here. Okay, in terms of what we would expect. It might still not working. Okay, we'll see if we can get that in a second. You may need to restart your computer.
Okay. I ain't got that folder.
You don't have that folder? Okay. So at the end of here, I'll get you hooked up with it. All right. So you'll see biology, chemistry, physical science, and physics. Generally, it's physical science if you're 9th grade, biology if you're 10th grade, chemistry if you're a junior, and physics if you're a senior. You need to have 3 sciences to graduate. It's a state requirement. The reason why we try and get 4 in here is because it looks good for college transcripts, for getting into college and getting scholarships. That's part of why we do that. It's part of the Kansas Government Region Scholar stuff. So I'm going to just pick one of these for now. Let's see, what do we got? Freshmen. Do we have any freshmen in here right now? One freshman? Yay. Sophomores? A couple sophomores. Juniors? A couple juniors. Seniors. Okay, we're all over the place. Fine. So I'll just start at the top. We'll do biology for the first example here. So now all of them will sort of look like this. And now you can make your own copy of these. Everybody know how to make a copy on Google Drive to get it for themselves?
Let's go to the file.
Go to File, Copy, make a copy, and then it will go to, you can choose which folder if you've got a folder for standards. So you don't have to come back and look at ones that don't apply to you. Only pick the one that's on your class list. Okay? So then, what we have is a list where you can put project names down, what you're working on, so you can kind of keep track of stuff, date you completed it. And then over here is a thing that we're trying to do where you got it, I come up, I check it off, I go, yep, Turner, I check it off. And I will keep track of those people in my FA, but I will also help with it. Anybody else, because I'm the science guy. Now each standard that I try to do is I try to have them by topic. So living organism. For chemistry, it might be atomic bonds. For physics, it might be forces, things like that. Physical science, forces also. It'll say at the top, demonstrate an understanding that living organisms, blah, blah, blah. That you can use as your problem statement. Okay. Say you want to do a project about this particular one. That's my problem statement. Then A, B, C, D, all these little bits under it, compare and contrast different common organisms, blah, blah, blah. those are your constraints. Justify the project, I need to learn the standard to get the science credit. That's it. If you want to do more than that, great. But as far as I'm concerned, for a science standard, bam, just pick it like that. Now, that's if you're just trying to do science. You might have other projects. We talked about yours with cooking, right? And electricity and cooking. You could.
Oh, we did talk about
Right?
my physics standard already, that's right.
So you could pick that electricity standard, add it into a project you're already doing. So if you're trying to figure out some of those, look through them. Does any of that look like what your project's about? That's one of the reasons why we want you to read the standards. Do you think that relates? If you're not sure, I'm the go-to guy on that. Come talk to me, I can go, yes, that relates. Or I'm doing a cooking thing, how does that relate? I can relate it to chemistry, I can relate it to physics. Science is in almost everything.
As it is, I'm very electric on my laptop, but it's not even connected to my laptop.
Okay. Hotspots are one of the things that causes problems with the laptops. So we'll look at that after, all right? So look through, find the different big topics. I tried to put them in gray. I'm still cleaning up some of this. But once you see things as demonstrate or whatever, it has an A, B, and C, that is one standard. Now, everybody understand the scales idea? I have a generic scale in that folder as well. So if you go to the student standards, there's a generic scale. And this is how we grade you. If you're trying a standard, you're at a 1. Doesn't matter if you know anything about it, other than, I'm trying to do this standard. I think it's part of my project. You're at a 1, because you're attempting it. All right? So you're working towards it. A 2 means that you can define the vocabulary that is part of that standard. You know what the words mean in it. Right? You can maybe do a simple explanation of how that standard works. So for example, back here in biology, demonstrate an understanding of the process of mitosis. Anybody know what mitosis is? No. Okay. So that would be a word. If you can explain that word, what that generally means, even if you just are rattling off a dictionary definition of it, you're at a 2. Because you're starting to learn what the word means. Meiosis, haploid gametes. Science is going to have a lot more vocabulary. So you've got to know the vocabulary. Because one of the things that will happen as you do this is you go, hey Turner, I got this thing and this is what we're doing. I'm showing this. I made a demonstration of meiosis. I built this bottle. I drew this picture, a comic strip about meiosis. Great. Tell me about this. What does that mean? What does this mean? That thing? I'll kind of quiz you on it. Or whoever your FA teacher might kind of go, how does this work? How does that work? Just see that you know what you're talking about. When you do that final bit there where you're showing us a thing, you're at a 3. You can make something that demonstrates it. Maybe you made a stop motion video of meiosis or mitosis, because that's about cells dividing. Right? You did clay and you had cells divide and divide again, and they're different parts. Awesome. You know what's going on, you showed us in the video. Woohoo! We get you at a 3. Now we might ask you some additional questions just to make sure you really got it. Great. That's a 3. That's the level we want you to be at for every standard. As soon as you're at a 3 for that level, I don't care if you go any further. 4 is you could teach that to other people. And you may do that. Maybe that's what you create a lesson to teach it, and you teach a class. Maybe that's the way you want to show your standard. That's your project. Sweet, I love it. We'll videotape it, we'll put it online so other people can learn it as well. That's great. But that's a 4, that's real high level. That's if maybe you want to become a science teacher, or you want to become a scientist. Shoot for that level. But 3 is all we ask you to get at. Once you have 90% of the standards at a 3. So if I go to biology, I go up here. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 standards. So you got 14 of them at a 3, you now have an A in the class. If you do that next week, you're done with science for the year. By the way, nobody will probably do that. That's a lot. That's a lot. But theoretically, you could do that. So you could be done with science first semester and not worry about it second semester, even though it's a year-long class. Show me the standard. Show me you know it at a level of 3. You're good. Okay. That's what we're shooting for. It's an A in the class, so 90% of the standards. Now let's say you don't get to 90% of them, you get to 80% of them. You got a B. You get to 70% of them at a 3, you're a C. 60%, you're a D. Anything less than that, you're an F. Hopefully that won't happen to anybody, right? Because that would suck. We don't want that. But that's the basic breakdown of that. All right, now, one of the standards in there's a standard in all of these that involve doing scientific theory or experimentation. Every single science class says, do an experiment. That's one of the standards. Now here's the cool thing about it. That's one standard. Pick another standard, combine them. Do an experiment about forces for physics. Do an experiment about living cells for biology. Do an experiment about chemical solutions for chemistry. You get 2 standards in one. Now, while you're doing this, I should mention this, you'll be doing lots of writing. That means you're getting what? English standards as well. Citing evidence is a big standard most of the places. So one of the things that you can do is you cite evidence about background knowledge. So I'm going to kind of run through how I would have you write up an experiment. Slightly different from a project, but still works. Any questions about the general standards? I know I just showed biology, but we can go, once I get over the general stuff, I can do specific questions about each class, all right? Maybe what some of those are. So, I'll have this online for you guys as well. I think it's already there, but I'll double check. Pick a standard. So we've got a standard that we want to do. And we write that down. So let's see. I'm going to pick atomic bonding is a standard. And that happens, I believe, in both physical science and chemistry. I don't have them all memorized because they're online. I can look them up. And if I want to do an experiment about that, I'm going to go online and I'm going to start looking. What have other people done as experiments? Because I hate to break it to you guys, probably none of you are going to discover something brand new that's never been done before in science. Possible, just unlikely. So do something somebody else has always done. Because here's the deal in science, one of the things that it should be is repeatable, which means if I do an experiment about atomic bonding, and then Nancy does the exact same experiment, we should get almost the same results. Because that's the way science works. It's repeatable. We know that it happens over and over and over again. We can use that to do things like make phones, make cameras, make cars. Engineers take the stuff scientists learn and make stuff. So we do an experiment. So we do this, we pick an experiment, go online, find an experiment, whatever it is, and you're going to perform that experiment. Now the first thing you have to have is, it usually starts with a question. Why do cakes turn from liquid to a solid when you put them in the oven? That's your question. That's a physical science thing. It deals with heat and temperature. It's a physics thing, heat and temperature. Changing from liquid to solid, that's usually a chemistry thing. So it could be a couple different ones. So you have a question. Let's start with, why does that happen? Or how does it work? Whatever the thing is you're curious about. Then you go find out. You go research. So we call that your background research. So I'm going to go look at America's Test Kitchen website, and they talk all about cooking and why does this work and what's the chemistry of that and blah, 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 blah. Or I'm going to go on to Khan Academy and read their chemistry section that has to deal with states of matter. Pick the section that applies to you, read it over, watch the videos, look for Bill Nye the Science Guy. Find videos online of other people talking about the stuff. Research it. Then, tell me what you learned. That may be a paragraph, that may be a page, that may be 5 pages, I don't know. It depends on how big your experiment is. Tell me what you learned and where you learned it from. So have a source. Then you're going to come up with a hypothesis. You guys have all probably taught hypothesis before in some science class, right? What's a hypothesis?
A scientific guess.
Scientific guess. So you're going to say, if I put a cake in the oven at 400 degrees, it will cook, 20 minutes or whatever. And then you're going to put together an experiment to test that. So you have a hypothesis. Now, this part is usually fairly easy for most people to do that part. Okay? Where it gets tough is in the experiment phase, because it's 2 things that are important to have. And that's your independent and dependent variable. You guys have heard those before, I bet, right? Probably since elementary school. So, the independent variable is the thing that you are trying to test, the thing that you're going to manipulate. So for example, I have a car, I'm putting it on a ramp and I'm rolling it down the ramp to see how fast it goes. But I'm going to adjust the height of the ramp. So one time I'm going to put it way up high and let it go down. The next time I'm going to put it down low and let it go down. Next time I'm going to put it way down low and let it go down. So I adjust that ramp. I'm manipulating it. I'm changing it. That is the independent variable. So this is the thing you change. The dependent is the thing that changes because of the thing you change. Because of that. So what might change because I change the height of the ramp? The speed that it goes. Okay, what else might change? Where it ends, how far it goes. So my dependent variable could be a couple different possibilities, but only pick one. Only pick one independent variable, only ever change one thing, only ever test one thing.
Alright, so we gotta do the screen, based on what?
Based on the standards. So some of the standards make a lot of sense to do experiments, some of them don't. Look at those and look for other videos that have already been done, experiments that have already done. If you look up physics experiments, chemistry experiments,
Alright, so
you'll
we're
find
gonna
tons of
say,
stuff. Yeah.
alright, when is that gonna be done?
By the end of the year.
Oh, damn, so you working on one thing?
Now, it's not going to be one thing, because one experiment is not going to cover everything. I mean, just like any classes a year long of science you've had, there's been lots of little experiments that you've done along the way.
Or,
You know, it's probably going to take more than one experiment. And some of these might end up being part of another thing you're doing as well. If you're doing an engineering thing, there is lots of stuff with forces and electricity that can be part of your experiments. Testing your product is an experiment.
so our grades for you going in tomorrow too?
Your grades for everything, go ahead.
Alright, so we working on some work with you, right?
So your grades coming up tomorrow are based on,
your work.
is based on what you've done so far with the design process. Okay? After tomorrow, we'll start doing more specific English, science, math standards, and the grades will separate based on what you're doing in that particular thing. Okay? So, once you've got those, you have to design your experiment. How am I going to do this? So that's the first tough bit, is designing that experiment, or is setting up your variables, then designing the experiment. This is the next tough bit, because you have to be very careful about what you do. Measurements matter. That's another standard in all of the science. So, doing experiments, taking measurements, and one other standard. You do one experiment, that could be 3 standards right there. Now you gotta do them good. Maybe you do the measurements good, but you don't do the rest of it good, so you get the measurement standard. And you maybe get English standards because you did good writing, you know, all of that sort of stuff. You have to get everything to a 3 eventually. But you could be tackling more than one standard at a time. Okay? And you may go back and do another experiment later on. Maybe your first experiment didn't go well, you were able to explain all of meiosis, but the experiment went awful. You didn't write that up well, you didn't show me that well. You got the meiosis, but you have to do something else, so you do another experiment. Your experiment goes well, and the explanation goes well. You raise it from a 2 to a 3, as I look at it. So you design your experiment. Your measurements have to be good. You have to be precise about how you do it. So if I am testing this car, I set up the car, I run it down the ramp, I'm going to run it down 10 times at 1 meter high. Boom, time it, boom, time it, boom, time it. Now, if I'm standing there and I let go of the car, and then I start timing, I've messed up because I didn't start it right then. I have to start it right then every single time. I have to be doing it precise, the same way every time. Now, if I let it go and start it when it passes a red line, every time, that works. Because I'm doing it the same way every single time. Because we want, again, only one variable. So before you do any experiment, I suggest strongly that you bring it to me, to Mr. Allen, Ms. Slocum, one of us to look over it and go, that looks good. You can go forward on it. Okay? Do that for us. That'll help you out. So, you've done your hypothesis, you've paired with your variables, you've designed your experiment, you're going to collect data. You're going to have it in a table of some sort. This may relate to some math standard you have. So maybe you're getting the math standard at the same time as you're getting the English and you're getting the science and all this other stuff. Science is that way. It's all things combined. Collect the data. You're going to analyze that data. Everybody know what mean, median, and mode are?
Yeah.
Those are the common things we do to analyze the data. What is the median time of the car rolling down the ramp? What is the average, the mean time of the car, or the average distance? Maybe we do a different experiment. Then you're gonna, in that analysis, tell me, was your hypothesis right or wrong? I think that the car will go further when the ramp is lower. And I find out that the car went further when the ramp was higher. Okay. Being wrong in your hypothesis means nothing.
No.
That's okay. Do it the right way. Tell me what the data really says. Don't try and make it fit what you want it to be. Tell me what it really is. I may want the world to be that I can eat desks and live off of desks. If I experiment on that, I may find out that I get really sick. Even though I want it to be one way, doesn't mean it is that way in the world. So, tell me what really happens. So you're going to do a lot of writing in your analysis. You're going to do a lot of writing in your background research. Here, you're citing evidence. That's an English standard for every grade level. Here, you're comparing and contrasting things. You're, again, citing evidence. You're making conclusions and assumptions. Those are all parts of the way science works. So, as you do this, and I'll have a form, like I said, I'll have a form online that'll explain every little bit as well. You can fill in the blank, kind of like that project template that you guys have used. Same idea. Okay? If you want to do an experiment at home, because you're doing a cooking thing and we don't have the stoves down here, or you're doing a thing that involves flinging watermelons off of a building and we can't get that set up here, that's cool.
Is it possible for us to get that set up here?
Some stuff, yeah. We can actually get on the roof to throw stuff off. All we gotta do is put the experiment together, show me that's what you want to do. I can go to Ms. Thompson and say, hey, we gotta do this experiment. Get us up there. She'll go, yeah. I've done that in past years with engineering things. We've had egg tosses where we throw eggs off the top of the building in special containers to see if they can survive and not get cracked. We had one that we threw off 4 times. We had to like throw it hard because we weren't high enough in the air to break it. So those are things we can set those experiments up.
Not bad. No, music though.
Okay. So, whatever you think you want to do as an experiment, fine, cool, let me know. Help me, talk with me through on the way. Now, you may, if I help you a lot on this process of designing the experiment, you may not get that standard for the experiment, not for the part it's about, forces, chemical bonding, living cells, whatever. That's okay, you can do another experiment later on. You can still get the other credit for other things. Just got to do it well enough. Eventually, the idea is you can get to the point where you can come to me with an entire experiment. You wouldn't have had to check with me anywhere along the way other than say, hey, am I good? I'll say, yeah, and let you go. Right? I can tell by just reading whether you got it set up right or not. I can tell by your analysis. Did you perform the experiment right? Do you understand what's going on? That's all you're going to do. That's a whole project right there. Now, some of those can be quick. You could probably write up and do one of these in 2 or 3 days. Pretty easy. Pretty easy.
Are you talking?
Yeah, I'm talking right now. So that's a thing you can do as a project. Get you English, get you math. Depending on what math you're in, there's graphing we can do to write equations. You can do linear stuff. You can do polynomial stuff, depending on the experiment. All sorts of things like that. Get math, get science, get English. All that crap. Now, you don't have to do experiments. You could write a science fiction story. Forces, acceleration, vectors, mechanical stuff. That's all spaceships flying through the air. You guys seen The Martian?
Yeah.
Okay. That was written by a guy who was a computer programmer and an engineer. He did research on it. He wrote up stuff, he sent it to other scientists and engineers to double check his work. That is one of the most scientifically accurate movies that has ever come out.
What?
The Martian.
It's a good movie too.
Okay. So there's a book out there. It's a good book. It's also a good movie. I know that Miss Wilcoxon has the book up there if you want to check it out. You can probably find the movie at Redbox or something like that. Yeah, it is pretty recent. I love science fiction stories. You want to write a story? I can check the science in it, no problem. I mean, the characters can talk about this stuff. I've seen it. If you're looking for examples, Isaac Asimov, Robert Heinlein, those guys were great writers who wrote good science as well. Their science was accurate in there. If you're looking for an example. If you're a writer type. If you're not a writer type, just read them for the fun of it. Okay? All right. If you got specific questions about specific classes, we can do some of that.
I don't like that standard for. Yeah.
Oh, you need the standard.
Share it to me too?
I
I
can.
don't have that.
All right.
I want the whole folder.
Yep, I will absolutely share you the whole folder. All right, so student standards. I'm going to share. All right, so I don't have your email. So your email 17 QIW.
GAR.
Oh, damn. Done it. Go straight to together.
So you can. All right, and we'll check that in a little bit when it comes to
Hey,
make sure you can
Sit down.
All right.
Oh, Go still there. Talking to. What we doing?
Okay.
What we doing?
If you don't have the standards folder, I'm sharing that with people now.
Are you shooting? All right, good.
So just get in line and I'll.
This our southern. What's up with big hands? What's up, bro?
Okay.
21.
Wait, y'all is classes 21, not 2020.
Shut up. I'm 300.
Yeah, you 300?
Yeah, I'm 300. I'm about to turn 600 on my birthday.
You is? How you 300 now?
Cause it be like that.
16.
No, it's not how, like, it's not how the number.
RIC.
You say you need to go to the bed.
It's hot.
Alright, Elijah, what are you, 17? 18?
My age?
No.
Oh,
For the email.
18, yeah, I am 60.
But then everything like.
I did, okay.
ELIMCD?
Yeah. You got the share with?
I am.
Alright, then we're coming from there.
Yep, you can check those out, start looking at stuff. Pick out the science things, you can talk more science with anybody. Okay, look, there's a resource page on there that has links to different places to learn the science. But there are tons of YouTube videos out there that you can learn it from. People who will teach it more exciting than me. You've already done it, you can watch it whenever you want. All right? But you have to do that. You can't just sort of jump in and think you're going to figure it out.
There you go.
That'll learn.
I'll fix it for you.